Federated learning is one of the most widely deployed techniques in the context of private deep learning. The term was coined at Google a few years ago by Brendan McMahon et al., and Google has been pioneering this field ever since. Federated learning is a technique for training machine learning models on data to which we do not have access. So basically, instead of bringing all the data into one machine, say in the cloud, and training a model, we're going to bring that model to the data, train it locally wherever the data lives, and merely upload model updates to a central server. So there's several use cases here where federated learning is quite interesting, but the first and probably most famous use case is in the context of mobile phones. If you're familiar with smartphones, when you open your texting app and the texting app tries to predict the next word that you're about to text, the machine learning model that actually does that, if you have an iPhone or Android, is actually trained using federated learning. Meaning when you go home at night and you plug in your phone and attach it to Wi-Fi, every once in a while it will actually do a bit of local training on your device, on your own text messages, and it will send a new model, a slightly smarter model, up to the cloud. And then later you'll get an updated aggregation of everyone else's model that also went up to the cloud, thus giving you a smarter model. And so the nice thing about this approach is that you're able to benefit from having this texting model inside your phone despite the fact that you personally are not generating enough training data for it to become intelligent. So you're benefiting from this model becoming smart by looking at thousands and millions of other phones without any of these people having to divulge the private information contained in their phone and without you having to divulge any private information within your phone. In the context of federated learning, there are also other applications that are very interesting. One interesting case is predictive maintenance. So, for example, if you own a car, every several thousand miles, you have to take it in to get an oil change, right? We just have this sort of fixed number of miles that we have to do this typically. But federated learning could be used to try to predict when your car needs to go into maintenance ahead of time by having a model that actually lives within all cars that are on the road, studying when they actually start to break down. So in this particular way, using various aspects of your climate, how you drive, the kind of engine you have, these kinds of predictive models could actually become intelligent in doing this. And the nice thing is that this wouldn't actually require you to upload any data from your car to some sort of central server. In theory, a model just comes down to your car, it learns how to predict when your car is going to require maintenance, and it uploads that ability to predict, an update to the model, back up to the cloud. Another interesting use case is in wearable medical devices. So you can imagine if you have one of those sort of fancy watches or wristbands that's tracking your movement, heart rate, or perhaps even your sleep cycles, or if maybe you log your diet online, one of these diet logging apps. You could imagine that federated learning would allow you to learn a machine learning model which could help you optimize certain parts of your health, whether it's your diet for having a better sleep cycle or how much you move during the day for accomplishing some sort of weight goal. And again, the nice thing here is that you by yourself are not actually generating enough training data to be able to train a model like this. But if you collaboratively train a single machine learning model with thousands or millions of other people, then everyone can benefit from this machine learning model without anyone having to upload their data to a central cloud. And finally, one of the other widely deployed use cases of federated learning is inside of mobile browsers, often in the context of ad blocking or an autocomplete. So when you go up to your browser and you start to type some website and it tries to predict what website it thinks you're trying to refer to, again, that's another example where federated learning has been used out in the wild to allow large groups of individuals to enjoy the benefits of ML models without having to upload all of their data to the cloud. So I hope these examples give you a sense for the kind of settings when federated learning is useful and really a context for the setup that leads to people wanting to use federated learning. The general challenge is that you have a scenario where a dataset is distributed amongst a large number of sources, usually because it's being produced by these sources, in the context of phones, a browser, wearable medical devices, or automobiles, for example. What you want to do is you want to be able to train a machine learning model on that dataset, but you aren't able to aggregate that dataset for a variety of reasons. Sometimes it's for privacy, right? There might be a legal restriction that prevents you from aggregating the data to a central server. Medical data, for example, has a lot of these kinds of legal restrictions. There might be user discomfort. So in the case of this ad blocker or autocomplete use case within browsers, people don't really want to upload every web page URL that they're going to some central server if they don't need to. And then of course, there are competitive dynamics. So if you think in the context of predictive maintenance, automobile companies might not want to upload to some central server every time one of their automobiles breaks down. Now, if it's just within one brand, maybe just Ford or something like that, that'd be great. But if you can imagine that, if Toyota could see when Hyundai cars break down because of some central server, there could be some strange competitive dynamics or leaks of potentially negative information. But federated learning isn't just about privacy. Often it's used because of engineering constraints. As it turns out, federated learning can actually be used to reduce the bandwidth cost of having to upload datasets to the cloud by allowing training to happen locally inside of these devices. So this is where the context of federated learning is an incredibly powerful tool. It's already been widely deployed to some very substantial use cases, and it's one of the things that's really advancing the fastest in terms of privacy-preserving technologies.